Hello, today we will talk a little bit about carbon dioxide and carbon dioxide sensors. Carbon dioxide is a component in the air in our atmosphere, and it has a big impact in the greenhouse effect and the climate change, of course, and has also an influence in our healthy life, actually, so a direct influence. You see we're having here 4 pillars. One is food, what we are eating, consuming. What we are eating we become, so we need vitamins and so on. Our body itself, we have to take care of it, we have to brush our teeth, we have to take a shower, and also, of course, making sports that the body stay long fit. And also taking care on our mind, that we are thinking in the right direction. When you are always thinking negative, can have a big influence in your healthy and happy life. And also a big part is breathing. So when we are not breathing for 10 minutes, we cannot survive. And when I work with students in this topic, and they're using like carbon dioxide sensors, they are quite happy just to read out something, but I try to guide them a little bit to look deeper into it, because you have to know about what you are measuring, how the quality is of your measuring. You know that when you measure with the sensor, you're having always a measurement chain. Nowadays, of course, it's all in one sensor, but the process is still there. You're having the sensor element and then the signal conditioning, sample and hold, RD conversion, and so on. And there always can appear errors which makes the value more or less accurate. And also when you measure something like air quality, you have to know first what you're really measuring. For example, the air itself, it contains nitrogen as the most part, with 78% around, and oxygen 21%. And when you're seeing that the rest are other gases, and from this the most even argon, then we're having here carbon dioxide with only 0.041%. We calculate it normally in parts per million, so these are 410 parts per million around. So there are a lot of people, no, not a lot, but there are a few people who are saying, but how can such a component have such a big influence, like for the climate change and so on. But it's not the amount, actually. When you're eating poison, like arsen or something, a small amount is enough that you are dying. And also for the effect which make the climate change, carbon dioxide, it's already a little bit can have a big influence on it. Let's take a look at the history from the carbon dioxide, at least the last 300 years. You're seeing here that at the year 1750 we have here under 280 ppm, and even until 1950 we have still 300 ppm, and then we have a quite high increase that we are at the moment at 450 ppm. And you see that's 60–70% more, and this is why we have a increasing greenhouse effect. And I mean, we're seeing a few effects from the climate change already. So we have really to flatten this curve here, not only because of the greenhouse effect, but it has also impact in the health as well. If we're looking inside, I mean, we know it from Corona, from the pandemic and so on, that we measure it, and that we have to exchange the air when the carbon dioxide level is too high to decrease infection possibility. And you're seeing here is a study what can happen on your health when we're having an increase on carbon dioxide. If it's under 300 ppm, of course we have nothing, but this outdoor is not even the outdoor level anymore, and it starts already with 950 ppm. We're getting a few health problems, yeah, like headache maybe, or dry skin, or increase in heart rate a little bit, and it's the effect increases, of course, also with the carbon dioxide concentration. Yeah, and let's say if it's already over 1,200, we have reduced cognitive function, so we should already exchange the air in the room. And this is actually not take so long. If you are in a small room and you are breathing there, then after 20-30 minutes you can have already this level of carbon dioxide in your rooms. So if you're making like an alarm warn system, could be something like this, yeah, that 400 ppm is still good, 600 is okay, and with 800 we would already have like yellow. It would be better if we open the windows, for example, and 1200 ppm already orange, and 2500 we should avoid, and then over 5000 over longer terms is not recommended in ppm. And you can see when outside is already now we're having 415. If it's still increasing, if we have outside already 600, of course it's not so easy to exchange to making a better air quality inside too. Yeah. And when we're seeing our body, why inside it's become so fast so high, the carbon dioxide, it's also because when we're breathing, we breathe in 21% of the oxygen, and the carbon dioxide is only 400 ppm. But when we breathe out, then we're having 40,000 ppm, so 4% carbon dioxide and only 70% oxygen. Yeah. There are a few sensors which you can work to detect carbon dioxide. One of the first sensors we are used is the ScioSense CCS811. It's it's an air quality sensor actually. It's it measures volatile organic compounds, and also on carbon dioxide equivalent. So it's only it's actually related to the volatile organic compound. These sensors can give you only a direction from the carbon dioxide. From our tests, it wasn't really accurate, but you can have at least a direction where it's going, the carbon dioxide. It's a metal oxide gas sensor, and I don't have so good experience with them. They are all not so accurate until now. Yeah. Then we also tried a sensor like this one, which is the MG811, and this is an analog sensor. Through heating you get a chemical reaction inside, you get an analog result. You have a quite complicated calibration process, yeah, and also the datasheet is only 2 pages and gives you not so many information. Carbon dioxide level you can measure from 0 ppm up to 50,000 ppm, and it has a high power consumption. So with an Arduino example which they describe, you need even external power supply. Yeah, and we didn't really get good accurate values when we tried it out. Yeah, so it's quite complicated to use. Then the company Sensirion made the SCD30, which is a quite interesting part already, and it's, for what we found out, already quite accurate. Yeah, it's measured 400 ppm up to 10,000 ppm. It has an integrated humidity and temperature sensor, and use it also for the algorithm and the calibration process. The accuracy is around 30 ppm, has a self-calibration mechanism, but you have always to look in the datasheet how something like this working. Yeah? When you're getting the first time results, they're sometimes even below 400 and so on. It's calibrate itself after a while. And with this, I don't know 100% at the moment. I think you have to expose it one time like the outside carbon dioxide level. Yeah, it takes as base level, so and then it's calibrated with it. When you're using it only inside and the level is always over 400 ppm, which what it's used to calibrate, then the algorithm doesn't work. You can also manually calibrate it when you know how the concentration is. You can set it. Yeah? It has the I2C UART interface and is a non-dispersive infrared sensor. Yeah? So it uses infrared. It has a power consumption from 90 milliamperes and measure it every 2 seconds. Yeah? You're getting new values which you can read out. The maximum consumption is 75 milliampere, which is also quite high. So to power it with a power supply with a bucket converter or so on, you have really to check if the bucket converter is strong enough for this. Then we're having another sensor from Sensirion, the SCD41, which is already much smaller than the SCD30. Yeah? It's also it's measured from 400 ppm to 5000. I mean, it gives you value much higher even, but then they are not really accurate anymore. Has also an integrated temperature and humidity sensor. It's actually the SHT41 inside, but it's not as accurate as when you're using the SHT41 separate. Yeah. And you're seeing here that the accuracy depends also a little bit on the ppm amount from carbon dioxide. Have the same, the self-calibration on manual calibration is possible. Has the infrared I2C interface, and it using a photoacoustic measurement sensing principle. Yeah, it's patterned. So this is why they can make it much smaller. And the typical power consumption when you measure every 5 seconds is 15 milliampere. When you're going down to 30 seconds, every 30 seconds the measurement, your power consumption will be 3.2 milliamperes. So it's still not less, but it's already okay. But you have to keep in mind that the maximum power consumption is 205 milliamperes, yeah, which is quite high. Like with the other sensor before, you need a bucket converter or something, a power supply which is strong enough. I will make here, we are testing the sensors that you see how they're working. I will not program it. When I start with the sensor, I'm using the Arduino IDE and the libraries for testing if they are working and how they are working. Yeah? But you have always to take a look in the data sheet, of course, too. The SCD, you just have to connect it with E2C lines, yeah, from your device, from the Arduino Nano. I take your Arduino Nano and I connect it with the power supply with the 5 volt, which is a little bit better because we don't have so much current then flowing there. Yeah? So the maximum current will be a little bit less. You're seeing here the SCD30, which is a quite big sensor. Yeah? You see how big it is. Here's the Arduino Nano and the connection. You see here a light which is lightning every 2 seconds. It's the heating process and the measurement every 2 seconds. And read it out. It's actually quite easy with Arduino, with the Arduino IDE. You have to install a library. You can just check the SCD30, and I used here in this case Adafruit library. Yeah? And then you're having on examples, Adafruit example test. You always should check here a little bit the serial baud rate, and if you have to set any I2C address or something, but here you don't have to set anything, you can just transfer this to the Arduino Nano. And then connect to the serial monitor. And you're seeing here SCD found, and we're seeing here temperature and humidity, and the ppm level at the begin. It's even over under 400 ppm. Yeah, so the calibration is not really done yet, but after a while you will get better results. When I breathe here, you're seeing it will also take a while until you're seeing here effect, but you see also the increasing, that the carbon dioxide level raises. Yeah, we have always like a hysteresis. It takes a while until it's going up and also until it's going down again. You see here the other versions, the newer version from Sensirion, the SCD41 in this case. Yeah, this is a developer board from Sensirion. Get it also a developer board from Adafruit and from DFRobot and so on. So having then maybe the SCD40 on it only, and you also connect it on the same way, I2C, and I power it in this case also with a 5 volt. Can either connect it with 3.3 or with 5 volt, as long you give it enough power, since the heating process is so long. Yeah, so for safety I'm using here the 5 volt in this case. And then I'm starting Arduino and searching again a library. Yeah, in this case I'm using the DFRobot library and using the example here. SCD4X makes a periodic measurement. And yeah, you can check, there's also only one E2C address. You can take a look in the datasheet then. It's not X62. So the serial baud rate is here the same. And for testing we can just transfer it and upload it to the Arduino Nano. And when I start then the serial monitor, seeing already a begin okay, the current temperature compensation value is 4, and the current environment altitude is 540. So this sensor has actually a lot parameters which you can set also. Yeah, this is why you have always to read the datasheet. It's measure carbon dioxide, which is at the moment still quite high, so it's also not calibrated yet, and the environment temperature and the humidity, and this every 5 seconds. You're seeing when you're seeing here the parameters in the source code, you can set some things like the altitude and setting as a temperature compensations. This is when you place it somewhere where it's quite hot and so on. So normal, the default value is, I think, 4 degrees because of the heating process. And also the altitude, you can set it here. I'm actually at the moment at 0, or let's say 10 meters. Yeah, so you have to adjust it that you're getting the best value upload it again, but it will not change so much. I mean, it's anyway calibrate itself after a while. Yeah, you're seeing here now, again it's going slowly down with these sensors. I know it's in the datasheet, you have to put it at least once a week in an environment where the ppm level is around 400 ppm. So this means outside, or you have to ventilate good enough that you're having an exchange with the outside air. But of course you can also make the calibration mode with a reference value if you have one. Yeah, and also here when I breathe there, you're seeing it's going up, the ppm rate. Takes also time because the measurements only every 5 seconds. When you're working with a sensor like this, you have always to take a look at the datasheet, and the datasheet from Sensirion are quite good. They give you a lot of information, yeah, like the accuracy and so on, the electrical specification, yeah, what is the maximum peak supply, so there's a difference with 3.3 volt and 5 volt. Then also the pin connection, and also the commands which you can send, of course. We're having here the I2C address 62 in hex code. They're using always a checksum, which you can calculate and which you have to calculate when you're sending the commands. And you're seeing here the basic commands and a lot other commands. You can make a periodical measurement. Then you're sending this command. It's always 16-bit what you're sending as command. You can set the temperature offset, the altitude from the sensor, the pressure. You can also set, when you have a pressure sensor, then you get also better results. You can make calibration and also get out a serial number here. And always every command a little bit described here. So this was it today about carbon dioxide and air quality. It's for me a quite important topic, and just reading out sensor value is not enough. Normally when you're working with sensors, you have to know what you are doing, what the effects are, how you can use the values and so on, if they're accurate or not, making testings. But especially air quality have a big influence on us. Yeah, we have things like particle matter, carbon dioxide, and a lot of other things. And yeah, the sensors can help us a little bit to decrease the effects maybe from the climate change, from bad air quality, and improve health for the people. Also in livestock, for example, you could check the air quality and reduce the amount of medicine which you have to give the animals when you can recognize something is happening there and so on. But it's still the beginning. Carbon dioxide sensor is already quite good from Sensirion. Temperature and humidity is also, we can get quite accurate values. But with a lot other things like ammonium and so on, it's still difficult with the sensors to get them, to get the accurate values. But the developing is going on there. So, if you want to support me, of course you can buy my book and give it a good rate, or just subscribe to the channel and give the video a thumb up. And see you in the next video.